Hello YouTube. So today I'm going to demonstrate a new feature that's coming in CIS 2.9. So this feature in CIS 2.9 enables you to configure advanced options when using the service type load balancer. So service type load balancer is really the simplest and fastest way to expose a service inside Kubernetes to the external world. So it's very common in public cloud, the use of service type load balancer, to have the cloud load balancer provide an IP to forward traffic to that service. So it's exposing that service with a IP address that is able to connect. And service type load balancers mostly really just layer 4. It's really just TCP port 80 or TCP port 443, and that's really it. And so the question is it worthwhile, or is it better to use service type load balancer with advanced services, like maybe using HTTP? That's a good question. Today, it's all just TCP. Could it be HTTP? Yes. But as of today, service type load balancer is really simple, fast, and effective. So service type load balancer is obviously supported by Kubernetes, doesn't really matter, and it's mostly used in public cloud, right? Because the IP is provided, that external IP. When you use service type load balancer on-prem, or if you want to use public cloud, it really doesn't matter. But if you want to use it, for example, on-prem, and you don't have that cloud load balancer, then you need something to provide that public IP. And within F5 CIS, we use an Ipam controller. It's basically F5 CIS Ipam controller, and that Ipam controller works in conjunction with CIS to provide IP addresses. And I'm going to show you that in a minute. And this is not new. CIS with Ipam was released a couple of releases ago, so it's been around. We're on like version 7 or 8 of it now, and soon we're going to actually just make it a 1.0 because we've added quite a bit of features. We've had quite a few people testing it, and it's actually looking pretty good. But what's really unique here is that with service type load balancer, with simplicity, really comes reduced complexity, which is kind of cool. And also, for the same, not only reduce complexity, but also reduce features. And so with service type load balancer, it's just TCP based. You might not necessarily have all your additional type of configurations that you potentially might have for an application that might have been on-prem, and now you've moved it into Kubernetes. And that could be quite important. So traditionally, with type load balancer, you're losing some of the functionality. Maybe that's functionality for manipulation of the data using something like an IRO, or maybe it's manipulation of enabling like a proxy protocol IRO, or it's custom TCP profiles and manipulation of the TCP headers, or manipulation of the TCP type profiles, whether it's WAN or LAN, etc., etc. Also potentially of the loss of doing some type of NAT, a SNAT, maybe some logging. And in this case, what's most important is potentially, since there's no virtual IP, right? Because you're not creating or configuring a virtual IP, you potentially could be losing out on some firewall DDoS profiles, right? So if you're wanting to firewall that specific, you could create the firewall manually, but the whole process of having this automated is to associate an IP address and associate that application's profile or that application's personality when you create the app within Kubernetes. But the app is created or deployed, and everything is controlled through the service because it's service of type load balancer. So there is no configuration of the virtual. However, what we can do with CIS, this can be solved by association of a policy CRD in conjunction with the service. And this is new in CIS 2.9. So for any of you folks that are using service type load balancer, now you can associate that policy. And the policy can really be anything. It's really up to you. So for example, policy, TCP profiles, IROS, SNAT, login, firewall, DOS, potentially bot. And this is traditional DDoS. This is not behavioral DOS because we're not at HTTP here. We're at TCP. But the IROS can be insecure, secure IROS. SNAT policy or SNAT pools is new in 2.9. There are some other items as well, but any kind of profile, right? Whether it's TCP profile, etc., and there's maybe some fast profiles as well that potentially could be added. So if we take a look at the example here, let's take a look of what's actually happening. So in this example, we have a service, and the service has an IPAM label. So the range is going to come from this range right here. So that's a range. It's a range of addresses. Think of it as a scope. And one of those IPs will get associated based on next address to be associated, right? And you can see here the association of the policy, or the plus of the policy. This is just a policy CRD. You create the policy CRD before you create the service. And you can see this is of type LB, and that's where it's invoked right there. You can see here's my L3 profile. This is my AFM profile. Here's my login. I am doing no persistence, and I am just doing a custom TCP profile. So that's actually really important. So if I log on to the big IP, and if I go down to security, go to network firewalls, you can actually see some active rules here. And you can actually see under my policies, there is my AFM policy right here. And if you actually look at my rules, what I'm actually doing here is in this rule, I can go look at rule list. In my rules here, I am saying only allow traffic to that range. So only allow traffic to the scope of that range and only allow specific ports. You can do anything here. I mean, this is actually pretty powerful. This is AFM. You can do whatever you want here with regards to only allowing traffic through the tunnel if you wanted to. Only allowing specific geo areas, like only allow traffic within the United States. Right? Anything else is blocked. You can also then lock down the device as well. Here I'm saying only allow communication to the external internal interfaces. So etc. This is really just AFM. This is your network application firewall that is created, and what you're doing is you're associating this firewall through the process of the policy CRD right here. And then of course you want to make sure that you're logging everything, and there's other values as well. So what happens is once you actually create IPAM and configure IPAM, what will happen is once you create the service, it will go and allocate the IP or release the IP. In this case, I'm going to allocate the IP, and then the status will come back and it will actually show up. And so in my instances, my IPAM is actually already created, but actually I don't have any services. So we can actually go and take a look at the configuration of once you deploy IPAM, you can actually see that that's actually the service that's created. But you'll notice that all that CIS needs is just IPAM is equal to true. You go and deploy CIS, make sure your cluster role binding CIS configured your CRD schema. And here is my range. You can see this is the range that I want to configure. So that's the same range that's in my AFM scope, to only allow traffic to this range. Anything else is denied. And you can see this is the IPAM configuration. So when you create IPAM, make sure you enable the rollback, the persistent volume. So I'm persisting the volume here so that I store it in the persistent volume, the IPAM deployment, and you can actually see the IPAM deployment is here, and you can actually see that these are the different configurations. This one here is associated, this first address associated to the service, and that was actually persisted there. So let's go ahead and take a look what this looks like when I create my pod, I create my policy, and I create my service. So if I go look on Big IP right now, there is nothing on Big IP. It has no virtual servers. If I try to connect to the app, you're going to see it's going to spinning right there. So there's obviously no app. Failed. Perfect. So the first thing I want to do is go into Kubernetes, and let's go here. Let me just take a look. I love monitoring this. You can see that was from a previous. I love monitoring the API, and it's the AS3 based API. So let's do a kubectl get service. There should only be the Kubernetes service. This is a generic Kubernetes service that's living on the system. We can do a kubectl get CRD vs policy. So you can see right here that I have a policy CRD that's already in place. So that policy CRD is exactly the same as in my diagram. And we can go and it's in my diagram right here. We can look at it. That policy CRD is the same as in the diagram as this right here. So if you wanted to actually see that, you could actually just go and look at my repo here. I could actually just click on the pod deployment. We can see the policy, and there's the policy right there. That's actually what is already deployed. I can edit that or view that in Kubernetes if I want, but that is already deployed. So the next thing would be to create the deployment, but I already have the deployment. kubectl, oh come on, get pod, and you can see there I have 2 test pods that are running. So if I do kubectl create, and there's the service right there, you can see that I invoked the logs. So there's quite a lot of logging. Ipam is there, it's syncing right there. There's the update. You can actually see, because I'm logging everything, it's of type LoadBalancer. There's the field, there's the status, and there is the successful API response. There's no errors, so that means everything in my policy CRD was completely accurate. If there was errors right there, maybe the policy wasn't on big IP, and you'd get a 422 error that's basically coming back from AS3 saying that the policies are missing. And so if I go back to the virtual server now, or just refresh, you could actually see that the virtual server is now there. And it's showing green because I have a health monitor as well. So if we look at this policy, if we look at this virtual, you can see there's the IP that was pulled from Ipam. You can see there's my custom TCP profile. I'm not worried about HTTP because I'm not doing HTTP. If I scroll down, there's pool members. I'm using source SNAT or SNAT of auto. You can change this SNAT profile if you want. In my policy, I'm not, because I'm just using this generic one. What's really important here is the resource type. So let's take a look. So you'll notice that I'm using no persistence. So I'm turning persistence off. So this is really cool, because if you don't do that, by default, your default persistence is probably going to be like source address or something. And maybe if you don't want persistence for the specific app, how do you control that through service type load balancer? Right? So this is the way to manipulate that. With security, let's take a look at the security profiles. You can see right here, here is my AFM policy. So now I know that this application is completely secured using a Kubernetes firewall. And you can see I'm logging. So if I go and try and connect to this app, you can see I'm able to connect to the app, no problem. And that's great. Let's take a look at the logs. So event logs, firewall, event logs, network, firewall. You can see that there is the connection right there. So this is my client. My client is going to this address of 244.20.60 is the pool member, and I'm connecting to this virtual. There's no region because I'm not using a region, and it's coming from external and it's going out of VXLAN. So that's kind of telling me where it's coming, where it's going. If I look at that address, is this the same address as? Yes. So you can actually see it is of that client IP. So this is actually within Kubernetes itself that is actually coming. This is actually this client address right here is actually the snatted address that's coming from the tunnel. So this 244.20.60, this is actually the big IP self IP, and that would make sense. And that's actually kind of where it's coming from. This is actually this server IP, which I don't see in here. That's just because big IP probably doesn't have visibility. Let's scroll across and let's see if there's anything more in these logs. I believe that is it. There's a couple more. Let's just make this a little smaller so we can see. Oh, brilliant. Actually, it does tell me where it's actually coming from, where it's actually going. So obviously these logs are quite detailed. So you can actually see that there is the, I know this is a little small, but there is the connection. That's the source address. It's for client, the source address. It's coming in on external, it's going out there. And this is the virtual IP, and there is the address. I'll make this a little bigger. There is the address of the actual pod itself. And how do I know that? As I can actually see it from here. See it right there. There's the address. So 215 is the address, and that right there is the firewall log. So that's actually pretty cool to get that level of firewall logging within Kubernetes. So now you can really control what traffic is coming into your cluster using a service of type load balancer. I didn't have to configure multiple CRDs and virtual servers or ingresses or routes or anything. I just use a very, very simple service of type load balancer with the additional features. So let's go ahead and recap what we did in this example. So we used the service of type load balancer in the simplest and fastest way to expose the service. We created that service, IP address got assigned through CIS Ipam, and we associated a policy CRD, which provided me some additional features that I think every exposed service should have, which is providing network-based firewalling on the virtual for that and created when the virtual was created. This is not just there for all services. This is created when the virtual was created. So I think that this is actually quite critical, and this should be a requirement for all Kubernetes services that are created, regardless of the location, whether it's on-prem or whether it's in public cloud. There should be some association of some network policy or network firewall that is associated that only allows traffic into the cluster. Before it even gets to the cluster, it's mitigated. So that's an example of something coming in CIS 2.9. Stay tuned. We've got 2 more sprints to go before we release CIS 2.9 mid-June. If you want to test this feature, please leave me a comment or send me an email. I can provide you with some early access images to do some testing, and you can provide me some feedback. Have a good day. And one thing is, if you like this video, please like with a thumbs up. If you're not subscribed, please subscribe, and let me know if you have any comments. Thanks.